This is how it flows. You know how it goes. And video notes are on the screen. You can't stop the flow. You just got to go. And video notes are on the screen. You can't stop the flow. You just got to know. Video notes are on the screen. Hey everybody, welcome to this week's installment of Video Notes for Mr. Flugum's physical science class. This week we'll be talking about circuits and current. Alright, these notes will go on page 49, and let's go ahead and get started. Alright, so just a little review here. This was on the last video notes. So remember, electrical current is when charges flow through a conductor, and in order for that to happen you have to have a closed circuit. So there's a picture of a closed circuit there, right? And that allows charges to flow uninterrupted. Remember, if you don't have a closed circuit, if the circuit's open, it doesn't work. Alright, so there's two kinds of circuits that we're going to deal with. We have series and parallel. Alright, so a series circuit is basically just one continuous circuit. There's no branches or anything else, it's just one straight line. There's only one way for the electricity to flow. You can see the picture there. Alright, and if you look, the electricity just goes in a circle like so. Right? Now with the parallel circuit, that means you have two or more pathways. So there's different ways for the electricity to flow. We'll find out in class that there's a big difference between these two. Alright, if you look in the parallel circuit I have there, there is 1, 2, 3 different ways for the electricity to get through the circuit. So that makes it, in a lot of ways, more efficient. Now one of the things we're going to do in class is this. We're going to be drawing circuits. So one of the ways you're going to show me you understand the difference between series and parallel circuits, and even what a circuit is you're going to draw it for me. So here's some of the symbols that we're going to use in class. Alright, and I'd like you to have these in your notebook, because we'll use them. Alright, we really will. And if you need to pause for a moment so that you can copy all these down, please feel free to do so. Alright, so using those symbols that were on the previous slide, I gave you a couple of examples here of drawing circuits. Alright, the first one's a parallel circuit, right? So if you notice a couple of things, one is that we've got two different pathways there for the electricity to flow. Alright, the second one is this. Notice from the negative there, this is the negative side of the battery, alright, that the electricity flows through the LEDs, right, in the direction that the arrows are pointing. Alright, the next one's a series circuit, and unfortunately I put switch there. There's no switch on that circuit, is there? So I crossed it out. And it has a buzzer and LED, and if you notice, that only has one pathway for the electricity to flow. Alright, so changing gears a little bit here, let's talk about electrical power. So remember a couple of chapters ago when we talked about power. Power is how fast energy is changed, or how fast work is being done, right? So electrical power is the rate at which electricity is changed. Alright, it might be being changed into sound or heat or kinetic energy, right? But how fast are you doing that, right? That's more power. Electric power is really easy to calculate. You just take the amps, right, the current, times the volts, right, which is the push that causes it to flow, and that gives you power, right? And of course the units are watts. Alright, as we talk about electrical current, we need to know this. There's two kinds of electric current. There's AC and DC, kind of like the band, right? So you got DC, which is direct current. That means the electrons only flow in one direction, like with a battery, right? Where they flow from the negative side of the battery through a circuit to the positive side of the battery. Alright, on the other hand, you have alternating current. So alternating current, right, the flow reverses direction or changes direction at regular intervals. Okay, so AC comes from like power plants or generators, and that's what we use in this school and in our houses, right? That's normal everyday electricity. So here's just a few things about direct current, all right? Most electronics use DC, so like our computers and your cell phones and your iPads, it's all direct current because that's how electronics kind of work, all right? And every time you use something that is electronic, it has a converter that changes that AC into DC current. You can see some advantages there of DC, all right? It can be safer, be lower voltage, and less dangerous, all right? But at the same time, you can't make it travel very far, and that's a big deal, all right? And the equipment can be hard to find, and it can be kind of expensive as well. On the other hand, we have alternating current, right, AC. So here in the United States, we use AC current that alternates at a rate of 60 hertz. So that means 120 times every second the electrons are changing directions. So the advantages of our AC are you can transfer them a long way. It's a much cheaper system to kind of use, and it's easy to change the voltage on it. Okay. On the flip side, though, it can be kind of inefficient. Right? It can be more dangerous, and you can't really store AC power. You have to change it into DC, so that can make things difficult. Well, thanks for tuning in, you guys, and be ready for the quiz on Thursday and Friday, and I hope you have a great week.